Zeophates, oxygen not included, tutorials, tips, and tricks. And welcome everybody to another episode of Tutorials for Oxygen Not Included. So today what I'm going to go over is going to be, I'm going to be going over plumbing. There's a lot of stuff here, but it all kind of serves various functions. First thing we need is, we need to be able to move liquid. Pitcher pump can reach down 4 tiles. Any liquid that it's below it in those tiles, it'll be able to draw up. Your dupes will manually go up and pump that liquid in. So, very early on, very first type of water source, that's it right there. So that's going to give you bottles. You can deal with bottles, well, you can deal with bottles 2 ways. You use bottle emptier, which the dupe will run up, drop a bottle on this thing, which you can at least turn in here and set it to whatever liquid you want. You have to have a bottle of this liquid laying around somewhere for it to have registered. The second thing you can do is use a bottle drainer. This will go directly into a pipe system. This dumps it in the world. This goes into pipes. This is from the new DLC Bionic, so most of you may not have access to this. Depends on whether you've got the DLC. Okay, well, how else do we move liquids around? Well, the final method is with pumps. Either a large one or one of the minis. Either way, they're going to require power, and they're going to draw liquid from their base and start pumping it up. If no liquid's on their base, they won't be able to pump it. From there, it's going to go into pipes. And this is where that green to white goes. Green's input, green's output, white is input. So to get the liquid out, you just put some drains. That'll cause the liquid to rematerialize in the world, fall right here, and start pooling. But you probably don't want to do that. Well, you may. Depends on what you want. For this system here, which is the system I'm going to use to demonstrate, we're going to go in, and we're going to look here. Actually, I'll get the pipe overlay. I have a water tank here. This is an infinite storage water tank. As long as those doors don't open, there's not any problem. If one of those doors opens, the water's going to go everywhere. I'll explain how to make those in a different video. But what's happening here is the pump is pulling the liquid in, shoving it into this pipe, which is then coming in and filling all the tanks on these lavatories and sinks. No big deal. From there, the output, or the polluted water, is listed all here. It's all outputting into the same channel, and it's going to flow up and along and go into our water sieve. From there, the sieve is going to purify it from polluted water into water. You will still have germs. And it's going to dump it out this pile here and through the drain into there. Now, what you can do if you really want to do it right is an infinite water system, which I'll explain now. We're going to disconnect that. So as it stands, right here, right now, this system's not going to get any more water into it. Period. Once it runs out of that, that's it. So this brings us to our next little tile here. And that is our liquid bridge. White is input, green is output. The interesting thing with the bridges is whenever water hits this tile, you can see the system in action right now. As soon as the water hits that tile, it's first going to flow that direction. This bridge overrides everything. It's going to go from there to there first. And then anything that it can't go shove into this section here is going to continue along the line and dump out into here. If you paid attention and noticed, this used or generated more water than was used. The reason for that is because of the lavatories. Because what it does is it pulls in 11.5 kilograms of water per flush. Here's the kicker. It produces 11.7 kilograms of polluted water per flush. So you're getting 6.7 kilograms more polluted water than you put in. Now, how does that help? Well, this thing is a 1-to-1 ratio. 5 kilograms of polluted water in, 5 kilograms of water out. So this right here, every time your duplicants use a lavatory, is going to generate you more water. So right there, you got an infinite set of water. Now, last little bit of plumbing. Really, a couple of different things we need to go over. First thing is pipes. First thing you need to know about any building really is the different materials you make it with have different effects. So depending on what your purpose for the pipe is, or any building really, you might want to change what material you're using. But first type of pipe is just our standard everyday liquid pipe. Moves liquids from point A to point B. It will exchange heat with the environment around it. So if you have cold liquid going through here and the environment's hotter than the liquid, it's going to transfer some of that heat to the liquid as it goes along. Opposite's also true. If the liquid's hotter than the air around it, it's going to transfer heat out. You may not want that, however, and that's where the insulated pipes come in. Insulated pipes massively reduce the rate for heat transfer. So if you've got really hot liquid that you're trying to move from point A to point B and you don't want it superheating the environment, you really want to use insulated pipes. The final type of pipe is the radiant liquid pipe. This pipe does the exact opposite of the insulated pipe. This massively increases the rate of transfer of heat. So if you got a hot room and you need to cool it down, this is one method. So that right there is the majority of what plumbing is. So now let's get on to some little specific pieces of equipment. First things first is we have the liquid filter. Okay, liquid filter, as you can see, it has 3 ports rather than standard 2. The way this works is liquid's going to go in, you're going to select your filter and basically tell it the kind of liquid it's looking for. In this case, we'll just say brine. And you're going to need to have a pipe hooked into the orange port and a pipe hooked into the green port. The way this is going to work is any liquid's going to go in. Anything that matches the filter is going to go out that orange port. Everything else is going to go out the green port. This filter, however, does take energy. So you are going to need to hook it into power. Next piece of equipment is we have valves. You've got your first valve, which is a manual system. You got your second valve, which you hook into an automation grid. And you have your third valve, which kind of self-regulates. Let's look at them each individually. The way valves work is they are going to restrict the amount of fluid or gases going through them. Right now they're set to 10 kilograms, so the maximum they can. You can set that to 1. You can even set that to 0. Shut it off. Downside with this particular valve, the first one we've got, is, well, it needs some manual input. The dupe's going to have to go in and adjust it. The liquid shutoff is for hooking into an automation grid. That'll have its own conditions for whatever you're trying to do, that it will trigger this valve to open or close. And then the liquid meter valve, now, it's basically a counter for liquid. Once a certain amount goes out, it's going to send a signal. And then from there, so the signal from this could trigger that to shut off. That it really is going to depend on how you want to use it. This one here, well, if you have a building or something that is generating a lot of heat, you're going to want to put this, because you can see it's allowing it to work, you're going to want to put this behind said building. Why? In this case, you don't want it to hook into any other pipes. By putting it there and then connecting pipes, it's going to allow the heat from that building to transfer into the liquid far more rapidly than anything else. So if you've got a building that keeps overheating, that's the way to control it. Last things we've got are, I'm not going to go over the rocket systems because I still need to work with them to figure them out. You've got sensors. These are used for the automation grid. Got 3 different types. First type, this one detects, well, what the liquid is. If a certain liquid trips it, it's going to act and send a signal, which could then turn on some things. This one here is for germs. You can set thresholds for it, but if it detects any sort of germs in the liquid, whether that be food poisoning, slime lung, or whatever, it'll send a signal out that you can then manipulate. And third is temperature. It's going to be looking for a temperature range. Above or below, you can set it to whatever temperature you want so that you can trigger whatever effect you want. One of the uses for this is if you have a cooling system set up using water, is you have a temperature sensor that opens a valve that's on the other side of a bridge so that liquid then starts flowing through it if it's above a certain temperature or below a certain temperature. And then you deal with it appropriately. Otherwise, most of the other blocks are pretty self-explanatory. They're just variations of the same. The water filler, just anything that gets piped into it, it's just going to be put into a bottle. It's useful if you need to transport liquids on occasion to remote areas. The wall toilet, well, it's just another type of toilet. This one, it's useful in outer space, or if you really don't care about everything else, because it's just going to, it's going to take water in, and then all that water is just going to fall out there. It's going to act like a, drain. So that is the water system. One thing to keep in mind, though, with these pipes, liquids can only flow in one direction. Again, going in here, liquids going from an output can only flow to an input. Here it can keep going, but it's going to go like this, or it's going to keep going on and up. Any liquid here cannot pass back and then go up. If you have two liquids that go in opposite directions, they're going to jam the entire system up. So having your directions good is a requirement. Worst case scenario, in order to force directionality, if you have a complex system and you've got a section that's causing some issues and you need to force directionality, simply come along, break the pipe, and chuck a bridge in place. That is going to force the directionality of the liquid. So that should hopefully help you solve some headaches. And that is liquids. Today, we're going to go over ventilation. Ventilation is very, very, very much, pretty much the exact same as liquids, really. All obeys the same rules as liquids, so really this part's done, because the buildings may change, but the way they work doesn't. The only difference is you got some vents, which I actually forgot to mention in the previous one. These will overpressure, and once they overpressure, they will stop working. Same thing will happen to the other one, but it's just massively higher. So if you've watched my liquid video, actually I'm just going to include this in the end of the liquid video, because there's no point in going over it all again. Because it acts the exact same way. Doesn't matter if it's a liquid, doesn't matter if it's a solid for an automation, for shipping, or if it's a gas. It all operates the same. So thank you all for watching. Hope you enjoyed. And we'll see you all next time.